During its recent mission, the James Webb Telescope made a fascinating discovery that could potentially provide evidence of alien existence. The world's most powerful telescope was directed towards the Kuiper Belt, where the former planet Pluto resides. Initially, scientists had hoped to gather some observations and capture images for further analysis. However, they were astounded when they noticed peculiar movements occurring on the planet's surface. The unusual phenomenon caught their attention, prompting them to investigate it more closely. What scientists and astronomers witnessed left them in awe. They pondered whether this strange occurrence could be the reason why Pluto was reclassified as a non-planet. Join us as we delve into the incredible finding made by the James Webb Telescope: the detection of a massive, elongated structure in motion across Pluto's surface. Embarking on a joint mission with the New Horizons probe, the James Webb Telescope sought to explore the intricacies of Pluto's surface. Scientists were perplexed when the images sent back by the probe depicted a mysterious object seemingly gliding across the planet's terrain. Despite attempts by the space agency to discredit this discovery, ufologists and alien theorists were not willing to dismiss it. They yearned to uncover more about this enigmatic moving structure. The image that is currently captivating the entire scientific and astronomical community was captured by the James Webb Telescope and transmitted via the Long-Range Reconnaissance Imager. This image expanded the telescope's and the New Horizons probe's highest resolution views of Pluto, providing an intricate glimpse into the Sputnik plenum, a region situated in the heart-shaped feature of the planet. Interestingly, the Sputnik plenum, although found at a lower elevation compared to its surroundings, is not entirely flat. Its surface is segmented into polygons or cells spanning 16 to 40 kilometers in width. When observed from specific angles, particularly with visible shadows, these cells exhibit raised centers and ridged margins, resulting in an overall height variation of approximately 100 meters. According to several researchers, the peculiar pattern observed on Sputnik plenum is likely a result of slow thermal convection within the nitrogen-dominated ices covering the area. It is believed that a reservoir of these ices exists, possibly several kilometers or miles deep in certain regions. Pluto's moderate internal heat warms the solid nitrogen at depth, causing it to become buoyant and form gray blobs. As the nitrogen cools off, it sinks back down, restarting the process. William McKinnon, deputy lead of the New Horizons Geology, Geophysics, and Imaging team from Washington University, likened this phenomenon to a lava lamp. One can imagine a lava lamp on a scale as wide and even deeper than the Hudson Bay. Computer models created by the James Webb Telescope team illustrate that these overturning blobs of solid nitrogen can gradually change and integrate over millions of years. The ridged margins observed indicate areas where cooled nitrogen ice descends and may eventually break off and be abandoned. It is possible that the X feature is one such region, representing a previous quadruple junction where 4 convection cells intersect. Additionally, multiple active triple junctions can be seen in other parts of the mosaic. Within the observation area of the James Webb Telescope, an informal region named Viking Terror on Pluto was also captured in the combined data. This image was taken from an impressive distance of nearly 49,000 kilometers, revealing features as small as 480 kilometers across. While analyzing these images, scientists and researchers were captivated by another phenomenon. They discovered bright methane ice condensed on many crater rims, forming a layer of dark red tholins, small, soot-like particles formed through reactions involving nitrogen and methane in the atmosphere. In lower areas, these tholins are predominantly found at the bottoms of craters, crater walls, and layered faces of steep cliffs. Scientists also observed that in regions where the surface appears smooth and the reddish material is thicker than usual, there is a high probability that the material has flowed into intricate channels. Scientists often speculate that deposits of such thickness are typically immobile on large scales. They hypothesize that these deposits might either ride along with the flowing ice beneath them or be carried by Pluto's winds. The images provided by the James Webb Telescope have revealed peculiar pits on Pluto's heart region. The extraordinary level of detail and the inclusion of color images of the dwarf planet's surface have further fueled the scientists' enthusiasm for research. Extensive investigations have led mission scientists to believe that these unusual craters may form through ice fracturing and evaporation. The scarcity of impact craters overlaying this area suggests that these pits formed relatively recently. They span hundreds of yards in width and tens of yards in depth. The alignment of these pits offers valuable insights into ice flow and the exchange of nitrogen with other volatile materials between the atmosphere and the surface. As scientists and researchers continued their observations using the James Webb Telescope data, they realized that Pluto's landscape is far more diverse than they had ever imagined. The latest set of high-resolution images of the dwarf planet provides an unprecedented level of detail, showcasing its remarkable variety. Notably, distinct snake-like patterns resembling the texture of snakeskin were observed on the surface. The clearest image capturing this phenomenon was taken near the twilight boundary, where day transitions into night. It revealed a vast rippling landscape characterized by peculiar linear ridges, leaving the New Horizons team members at NASA astonished. "It's a unique and perplexing landscape stretching over hundreds of miles," remarked William McKinnon, deputy lead of the New Horizons Geology, Geophysics, and Imaging team from Washington University in St. Louis. He compared the appearance to tree bark or dragon scales rather than typical geological formations. Understanding this landscape will require considerable time and effort, as it might be influenced by a combination of internal tectonic forces and ice sublimation driven by Pluto's faint sunlight. Scientists are still uncertain about the exact cause of the pattern observed on Pluto's surface, but several theories have been proposed. These include the potential impact of plate tectonics creating ripples on the surface or the release of frozen gases as surface temperatures increase. The image resembling snakeskin on Pluto's surface is just one intriguing piece of data recently sent back by the New Horizons spacecraft. In addition to this, the spacecraft captured the highest resolution color view of Pluto to date, along with detailed spectral maps and other high-resolution images. The newly extended color view of Pluto reveals the remarkably diverse and vibrant color palette of the planet. It has been almost 8 years since NASA's New Horizons probe flew past Pluto, yet this epic encounter continues to yield valuable scientific findings. Humanity was granted its first up-close look at Pluto when the probe zoomed in at a distance of only 12,500 kilometers above the planet's frigid surface. The mission team is still in the process of analyzing the vast amount of data collected by New Horizons during the flyby. Intriguing discoveries are continuously being made as new results emerge. The latest findings from New Horizons researchers were shared at the Lunar and Planetary Science Conference held in Texas, both in person and virtually. These discoveries included insights into the mysterious flip of Pluto, the peculiar landscapes found on the planet's surface, and the composition of the snowman-like object known as Arakoth, which New Horizons and the James Webb Telescope observed. While scientists have known that Pluto experienced a flip in its orientation similar to Earth, the specifics of its pre-flip state and the extent of its reorientation have remained unclear. Researchers utilizing New Horizons data to study Pluto's geological history aim to uncover clues that could explain this event. A group of researchers has now linked Pluto's flip to the formation of Sputnik Planitia, a 1,000-kilometer basin comprising half of the iconic heart-shaped region on Pluto. Previously, scientists understood that Sputnik Planitia, filled with nitrogen ice, played a significant role in realigning the planet's surface. However, by examining images captured by New Horizons during the flyby, researchers are now attempting to trace the path of Pluto's flip. In doing so, they have identified parallel mountain ranges and deep valleys that form what appears to be a global tectonic system. These features span a distance of over 300 kilometers and are distributed similarly from Pluto's North Pole. Nevertheless, the revelation that Pluto underwent a significant change in its orientation in the past implies that none of the currently observed terrain is in its original position. Oliver White, a co-investigator of the New Horizons mission at the Search for Extraterrestrial Intelligence Institute in California, explained during a presentation at the Lunar and Planetary Science Conference that this indicates these features likely existed near Pluto's equator initially and later migrated to their present locations near the poles due to the planetary flip. White's research team also discovered that Pluto's subsurface ocean likely played a role in pushing Sputnik Planitia and shifting a significant portion of the dwarf planet's mass towards its equator. In addition to shedding light on ancient landscapes on Pluto, the data from the James Webb Telescope and New Horizons mission provide insights into more recent features. The spacecraft previously identified extensive methane deposits, some as tall as Earth's skyscrapers, near Pluto's equator. Furthermore, scientists now have evidence suggesting that knife-like landforms similar to Earth's penitentes extend to the far side of Pluto beyond the reach of the James Webb Telescope and New Horizons during their flyby. The discovery of these features contributes to our understanding of the processes shaping Pluto and other icy planets in our solar system. It highlights the intricate dynamics, complexity, and diversity of planetary surfaces, such as that of Pluto. Ashan Mishra, a postdoctoral researcher at NASA's Jet Propulsion Laboratory in California, stated that on Earth, similar structures are known as penitentes, consisting of water ice and spanning only a few meters. On Pluto, however, these features primarily occur at the highest points on the surface, towering hundreds of meters in height. At such elevations, methane freezes out of Pluto's wispy atmosphere in cold temperatures and evaporates back into a gaseous state during warmer periods. In this recent study, the research team utilized images captured by the Long-Range Reconnaissance Imager on the New Horizons spacecraft. They focused on analyzing the changes in light reflection from different surface angles, ultimately identifying similar methane absorption features on the far side of Pluto. This discovery was attributed to the roughness of the surfaces, which Ashan Mishra highlighted during his presentation. Furthermore, Mishra noted that these blade-like terrains are likely among the most prevalent landforms on Pluto. During its journey, New Horizons encountered a small object in the Kuiper Belt named Arrokoth, which resembles a partially flattened snowman. Located at a staggering distance of 6.6 billion kilometers from Earth, Arrokoth holds the distinction of being the farthest object ever explored by a spacecraft. Its remoteness from the Sun keeps it in a state of deep freeze, contributing to its primitive nature. Scientists revealed that Arrokoth is the result of a gentle fusion between two objects that once orbited each other. Specifically, the larger of the two lobes, known as Ultima, was composed of 12 rocks gathered around a larger central slab. The latest findings indicate that Ultima formed not as a single entity, but rather from pre-existing rocks in the outer reaches of the solar system. This surprising discovery adds another piece to the puzzle of how planetesimals, the building blocks of planets like Arrokoth and other objects in the Kuiper Belt, come together. Principal investigator Alan Stern from the Southwest Research Institute in Colorado commented on the significance of this finding. He stated that throughout the history of the solar system, millions of kilometer-sized icy objects were dispersed within a vast donut-shaped region known as the Kuiper Belt. At the edge of this belt, a few of these objects amalgamated to form Arrokoth. Importantly, the merging of these tiny objects occurred at relatively low speeds, explaining the elongated shape observed in Arrokoth. When objects merge at high speeds, their rapid spin causes material to be thrown away, resulting in the formation of circular bodies. In the case of Arrokoth, however, the rocks retained their shape even after merging, indicating a lower merging speed. According to Stern's team, they estimate that the rocks would have been traveling at less than 1 meter per second when they coalesced. Previous research revealed that Arrokoth had interacted closely with the smaller object, and both objects lost some angular momentum by ejecting material before eventually merging to form the present-day Arrokoth. Stern emphasized the significance of the individual rocks, describing them as resembling Lego pieces in terms of size, composition, and color. These characteristics provide valuable insights into the formation of Arrokoth. During Stern's presentation, he explained that the 12 rocks comprising Arrokoth are more than 5 kilometers wide. Given that Arrokoth is only 10 kilometers thick, scientists believe that these 12 rocks clustered around Bennu's equator constitute the majority of Arrokoth's body, extending to its far side, which was not observed by New Horizons. Looking ahead, the James Webb Space Telescope's first mission this year will focus on studying Pluto and numerous other celestial objects in the Kuiper Belt, a region beyond Neptune's orbit in our solar system. These objects, known as Kuiper Belt objects or trans-Neptunian objects, exhibit remarkable diversity in terms of color, shape, size, groupings, clusters, and geological and atmospheric activity. While previous spacecraft, including NASA's New Horizons mission, have provided brief observations of these objects, the James Webb Space Telescope, with its sensitive infrared cameras, will enable scientists to study them over an extended period. This extended study will yield valuable information about surface chemistry, potentially providing clues about the diverse populations present in the Kuiper Belt. Heidi Hamel, a James Webb Space Telescope interdisciplinary scientist for solar system observations, expressed excitement about studying these objects and their potential to shed light on the early stages of the solar system. Describing them as objects in the graveyard of solar system formation, Jonathan Lunan, an astronomer at Cornell University and a James Webb Space Telescope interdisciplinary scientist, noted their likely existence for billions of years and their potential to endure for billions more. Additionally, the James Webb Space Telescope will also investigate objects known as centaurs, and scientists anticipate more surprises to come. The future discoveries of the James Webb Space Telescope hold great intrigue, and readers are invited to share their thoughts and predictions in the comments section below.